Ever wondered how machine learning algorithms group similar data? Well, sit back and relax, because today we're diving into the intriguing world of K-means clustering. It's a term that might intimidate some, but in reality, it's a fascinating technique that helps us make sense of complex data. Imagine a room full of scattered toys. Now, if you were asked to organize these toys, you'd probably group them based on similarities, right? Maybe by color, size, or type. This intuitive process is what K-means clustering mimics, but in a more sophisticated and mathematical way. K-means clustering is a type of unsupervised learning algorithm in machine learning. Now, don't let the term unsupervised scare you. It simply means that this algorithm can work its magic without the need for pre-existing labels or classifications. It's like a self-starter, figuring things out on its own. So you might wonder, how does this algorithm accomplish this task? Well, K-means clustering starts by randomly choosing a certain number of cluster centers. Picture these centers as team captains picking their teammates in a schoolyard game. The number of centers, denoted by K, is determined by the user, hence the name K-means clustering. Next, the algorithm assigns each data point to the nearest cluster center, based on some measure of distance. Think of it as each toy gravitating towards the team captain, or cluster center it resembles the most. The centers then move, or update, to the average position of their assigned points. This process repeats until the centers no longer move significantly, and the teams or clusters become stable. But here's an interesting question. How does the algorithm decide what's near and what's far? Well, it typically uses something called Euclidean distance, which is just a fancy way of saying it calculates the straight line distance between 2 points, much like how we'd measure distance on a map. So to summarize, K-means clustering is a method used in machine learning to group similar data points together. It does this by randomly selecting cluster centers, assigning data points to the nearest center, and then updating these centers based on the average position of their respective points. This process continues until the clusters become stable. Remember, the goal here is not to get lost in the jargon, but to understand the concept. K-means clustering is just like organizing toys into groups, but with a touch of mathematical elegance. It's a powerful tool that helps in data analysis, pattern recognition, and even in making recommendations. So the next time you see a group of similar items, think about the beauty of K-means clustering and the magic it does behind the scenes.